This was one of the problems I solved earlier on today, the first example. Assuming we have found the Maclaurin series for your y, which I have written out this Maclaurin series here also. This is the Maclaurin series. Now in part 3, which is what we want to focus on, they tell us to now use standard series and go and verify your answer. They already guided you, I want to use standard series. So what's the standard series that you want to apply? This is our y. From the initial equation, can we write down what is y first, with y being the subject? Okay, so like we have just now, we will ln both sides. And it will be then clear that I need from the formula list a sine expansion, which I have listed, and also a ln expansion, which is ln 1 plus x. So which should we use first? Should we start with ln or we start with sine? Always start from inside. If you have a choice of two and you have a bracket, start inside first from the bracket. Then you go outside later. Observe which power you want to go up to. I would like to go for expansion up to x cubed. So when I apply the ln and sine expansion, we will aim for up to x cubed. Anything more, no need to write. Okay, only up to the terms that they want. So I change my sine x into these terms, x minus your x cubed over your 3 factorial is 6. Then you try to apply ln, but ln takes a very special format. It must be of the form 1 plus a variable. Within the ln must be the constant 1 and must be a variable that comes next. So there's one technique that you need to know. For ln equations, if you don't have a 1 at this particular step, you go and factorize. At this point, I'm going to factorize 2. I want to force it to be a value 1. So when I factorize, this becomes 2 first, still within the ln, and you change everything to be divided by 2. I take out 2 from all the terms, so I will get a half and a 1/3. And the trick is, this is a multiplication for ln. I can open up as addition. We will have ln and 1 plus this. Which this forms your now new x. Let me call this as a new x. So it is possible that when you apply the ln expansion, this x here can be multiple terms. In this particular instance, this whole thing in the red bracket will be used as the x. There is 2 terms substituted to this x here. Okay, this new x will have 2 terms. So I apply it on that next line. First term is x, and x is now 2 terms. Second term is x squared over 2. So I'm going to write the half first. And then we go for x squared, which is this expression. Okay, the new x is now placed into the x for the ln. And third term will now be plus 1/3 x cubed. And I would like to stop up to the x cubed term. Let's simplify. What do we need to consider? You would like to expand. So let's say this is a plus b squared. You would like to consider the terms a squared plus 2ab plus b squared. You need to think about this, but you can do it mentally because I just need to check for the terms that are cubic and below. Cubic and below. What will be the power of your b squared? If you take x cubed square, you get degree 6. Too big. AB, you multiply these two, you get degree 4. Also too big. So actually, you don't need this term altogether. I don't have to write. Because this term multiplied to any other term will give you a degree larger than 3. So the only term that I have is only the half x. Mentally, I will think through, I need 2ab and b squared, but it's too large. And it will be even worse for the cubic term. This term completely we will ignore. You're going to multiply 3 times, it gives you a large power. Okay, hence for that last term, it will just be 1/3 and half x cubed. Okay, and we just finish up and simplify your numbers. This is what we will get from this expansion.